Hello students, we continue with the problems on regular falsi method. Now fifth problem, find the real root of the equation f of x equal to x e power x minus 3 equal to 0 in the interval 1, 1.5 by regular falsi method correct to 3 decimal places. Now we start the solution. Let f of x be equal to x e power x minus 3 and a is given as 1, b as 1.5 because we have to choose a and b such that a is always less than b. So that f of a, which is f of 1, minus 0.2817 which is less than 0, f of b, that is f of 1.5, f of 1.5 is 3.7225 which is greater than 0, so f of 1 into f of 1.5 is less than 0. If this condition is satisfied, then we can say there exists at least one real root in the interval 1, 1.5. As usual, the regular falsi method is given by x equal to a into f of b minus b into f of a whole divided by f of b minus f of a. Now we prepare the following table. A is 1, b as 1.5, f of a minus 0.2817, f of b plus 3.7225. So with all these values, if you calculate x by using this formula, we get x as equal to 1.0352 here. Then if you find f of x, that is f of 1.0352, we will get minus 0.0852. So f of a into f of x, the sign minus into minus plus, again positive. We know that what we have to do, if f of a into f of x is positive, we have to write x value under the column a. B is same 1.5. F of a we have calculated here minus 0.852. F of b is same. If you apply the formula, this formula, we get 1.0456. F of x as minus 0.0252. Again f of a into f of x comes out to be positive. Again we will write x value under the column a. B is same 1.5. F of a we have calculated here. F of b same. Then we get f of x as 1.0487 by using this formula. Again if we find f of 1.0487, which is f of x, which is minus 0.0071. Again f of a into f of x is positive. We write x value under the column a 1.0487. B same. F of a is already calculated. F of b is same. X value comes out to be 1.0496. F of x is minus 0.0018. Sign of f of a into f of x is positive. Again, if the sign is positive, we write x value under the column a. Then b as it is 1.5. F of a is calculated value. F of b, x we will get as 1.048498. And if we calculate f of x, which is very small value, minus 0.0006, x, you can observe here, it is correct to 3 decimal places. In 4th and 5th step, values are same. So the required root is x equal to 1.049, correct to 3 decimal places. Now 6th problem, find the real root of the equation f of x equal to 2x minus log x to the base 10 equal to 7 in the interval 3.5, 4. So the interval is given, so we can choose A as 3.5, B as 4. By regular falsi method, correct to 3 decimal places. Now solution, f of x is 2x minus log x to the base 10. If you take 7 to the left hand side, minus 7, a is 3.5, b is 4. So f of a, f of 3.5, which is minus 0.5441, which is less than 0. F of b, which is f of 4, the value is positive. So f of 3.5 into f of 4 is less than 0. If this condition is satisfied, that is f of a into f of b less than 0, then there exists at least one real root in the interval 3.5, 4. The regular falsi method is given by the formula x equal to a into f of b minus b into f of a whole divided by f of a, f of b minus f of a. Now we prepare the table. First approximation or iteration, a is 3.5, b is 4, f of a is minus 0.5441, f of b 0.3979. So x value we will get it as 3.7888. F of 3.7888 is minus 0.0009. So f of a is negative, f of x is negative, so this one has to be positive. We know that if f of a and f of x is positive, we have to write x value under the column a. So a is equal to, so a is equal to 3.7888, b is same 4, f of a minus 0.0009 here calculated, f of b is same. With this all values, if you substitute in x, it comes out to be 3.7893. Now f of x, if you calculate, you will get 0.00001. Now dear students, observe f of a is negative, f of x is positive, so the product has to be negative. Now if the product is negative, we know that we have to write the x value under the column b. So we will write a as it is, b is this value, f of a is already calculated value minus 0.0009, f of b is here 0.00001, x we will get it as 3.7893. So correct to 3 decimal places, we can observe in step 2 and step 3, x value is same, that is, so the required root is x equal to 3.789, correct to 3 decimal places. Now 7th problem, find the root of the equation x cube plus 3x plus 4 which is 0, which lies between minus 2 and minus 3, using the method of false position, which is same as regular falsi method, 3 times in succession. So same method, but we have to very carefully choose a and b value, because we have to always choose a and b such that a less than b. Let f of x be equal to x cube minus 3x plus 4. So we have to choose a less than b. So a is minus 3, b is minus 2. So f of minus 3, which is minus 14, which is less than 0. F of minus 2, which is plus 2, which is greater than 0. So the product of f of minus 3 into f of minus 2 is less than 0. It has to be. So the condition is satisfied. So there exists at least one real root in the interval minus 3, minus 2. Now what is the formula? The regular falsi method is given by the formula x equal to a into f of b minus b into f of a whole divided by f of b minus f of a. Now we prepare the following table. Same table. First iteration, a is minus 3, b is minus 2, f of a is minus 14, f of b is 2. So we will get x value as minus 2.125, f of x as plus 0.7793. So students, here the sign of f of x is negative, because f of a is negative, f of a is positive, so the product is negative. If the product is negative, we have to write x value, this value, under the column b. So in the second step, we write a as it is minus 3, b minus 2.125, f of a is minus 14, f of b we will get from this step 0.77930. If you calculate x, it is minus 2.17114, and f of x is plus 0.27899. Again observe, f of a is negative, f of x is positive, so the product is negative. Again we have to write x value under the column b. In the third step, we write a as it is, f of a as it is, f of b from this. So if we again calculate x value, what we get is minus 2.187. Here the question is, we have to find the third approximation. So the third approximation is this one, minus 2.1873. Now next problem, 8th one. Show that a real root of the equation tan x plus tan hyperbolic x equal to 0 lies between 2 and 3. How to show that it lies between 2 and 3? We have to show that f of 2 into f of 3 should be less than 0. Then apply Regula-Falsi method to find third approximation. So f of x is equal to tan x plus tan hyperbolic x, f of 2 minus 1.221 which is less than 0, f of 3 0.8525 which is greater than 0. So f of 2 into f of 3 is less than 0, which implies f of x equal to 0 lies in 2, 3. So the first part is done, that is the real root lies between 2 and 3. Now we will choose a as 2, b as 3, f of a we know minus 1.221, f of b 0.8525, and the formula, the Regula-Falsi method, is given by x equal to a into f of b minus b into f of a whole divided by f of b minus f of a. Now we prepare the following table. First step, a is 2, b is 3, f of a minus 1.2121, b is 0.8525. So if we apply the formula, we get x value as 2.59, f of x 0.3735, but you have to be careful, it is trigonometric function. We have to use calculator in radian mode. To get tan hyperbolic x in calculator, there is one button HYP. So to get tan hyperbolic x value, we have to type HYP tan of x value, which comes out to be 0.373, f of x 0.3735. Now again find what is sign of f of a into f of x. F of a is negative, f of x is positive, so the product is negative. We know that if the product is negative, we have to write x value under the column b. So a value we will write as it is, f of a also same, f of b is here we have calculated value. Again if we calculate x, we get x as 2.4518, f of x as 0.1603. Again the product is negative, because f of a is negative, f of x is positive. So again same steps, if the product is negative, we have to write x value under the column b. So a is same, f of a is also same. We have calculated f of b already in the previous step. So x value we will get it as 2.3994. Only 3 approximations are asked. So the required root after 3 approximation is x equal to 2.39. 9, 4. Now, fourth problem. Use the regular Falsi method to find fourth root of 12 correct to 3 decimal places. Solution. Let x be equal to fourth root of 12. So we can write x4 is equal to 12. So, or we can write it as x power 4 minus 12 as 0. So we take x power 4 minus 12 as f of x. So we have to find a and b value with a is less than b, and the other condition is f of a into f of b must be less than 0. So we start with 0. F of 0 means minus 12, which is less than 0. F of 1 means it is minus 11, which is also less than 0. Dear students, we have to get one value is less than 0, other value is greater than 0. So f of 2 is 2 power 4, which is 16 minus 12, 4 greater than 0. So f of 1 into f of 2 is less than 0. So we can conclude that there exists at least one real root in the interval 1, 2. We take a as 1, b as 2, f of a is minus 11, f of b as 4. Now we prepare the table. So this table, we start with first approximation. Iteration 1, a is 1, b is 2, f of a is minus 11, f of b is 4. So by using all these values in x, this formula, we get x as 1.7333, f of x as minus 2.9733. So sign of f of a into f of x, negative into negative, positive. Second step, if it is positive, sign is positive, we have to write x value under the column a. So b we will write as it is. F of a we have calculated here, the same value has to be copied here. F of b is 4. X we will get it as 1.8470. F of x as minus 0.3619. So negative into negative, again positive. Third step, again we will write x value under the column a. B is 2. F of a is minus 0.3619. F of b is 4. X value we will get it as 1.8597. F of x value as minus 0.0390. Again f of a into f of x is positive. We will write x value under the column a. B is same 2. F of a we have to copy from here. Then f of b is 4. X we get as 1.8611. F of x is minus 0.0040. Again we get positive. So we write x value under the column a, 1.8611. B is 2. F of a we have copied from here, 4. So we get x value is 1.8612. So correct to 3 decimal places. If you compare fourth and fifth approximation, we get almost same value, 1.861. So therefore required root correct to 3 decimal places is x equal to 1.861. Now we move on to next problem, 10th one. Find the negative root of the equation x cube minus 4x plus 9 equal to 0 from the regular Falsi method correct to 3 decimal places. So let start with f of x, which is x cube minus 4x plus 9. Now we have to find a and b value. We have to find negative roots. So first we start with f of 0, which is 9 greater than 0. F of 1, still it is positive, 6 greater than 0. F of 2, again we get 9, which is greater than 0. So what we do is, I will start, since for 0, 1, 2, 3, etc. I will get only positive value, that is greater than 0. I will go with minus 1. Now x equal to minus 1. So I will take minus value, which is 12, which is greater than 0. F of minus 2, which is 9, greater than 0. f of minus 3, which is minus 6, which is less than 0. So f of minus 2 is 9 greater than 0, f of minus 3 is minus 6 less than 0. So f of minus 2 into f of minus 3 has to be less than 0. So if this condition satisfied means there exists at least one real root in the interval minus 3 comma minus 2. So we take a as minus 3 because we have to always take a less than b as minus 2. So f of minus 3 is minus 6, f of minus 2 is 9. With this, we write the formula. The regular falsi formula is given by x equal to a into f of b minus b into f of a whole divided by f of b minus f of a. Now we prepare the table. First step, a is minus 3, b is minus 2, f of a is minus 6, f of b is 9. With all these values, if we calculate x, we will get it as minus 2.60. If we get f of x, that is f of minus 2.60, we get it as plus 1.8240. Now f of a is negative, f of b is positive, so it has to be negative. So if the value is negative, then we have to write x value under the column b. We have written here. Minus 3 is a value, f of a is remains same, f of b is we can copy from here. Yeah. Then again if we calculate x, we will get it as minus 2.6933. So f of x we calculate, if we calculate 0.2372, we get again f of a into f of x comes out to be negative. If it is negative, we have to write x value under the column b. So b a is same, f of a is same, f of b value is copied from here. Again if we calculate x, we will get minus 2.7050, 0.0281 f of x we get. Again product is negative. Fourth step, now a is minus 3, b is from here minus 2.7050, f of a is minus 6, f of b is copied from here. Again calculate x, we get minus 2.7064. f of x we will get it as 0.0027, which is negative. If it is negative, again I have to get back x value. I have to write x value in b. So a is minus 3, f of a is minus 6, f of b is 0.0281. So x value we will get it as minus 2.7078. f of x value, if we calculate, it is negative. So f of a is negative, f of x is negative, so it has to be positive. If it is positive, we have to write x value under the column a, which is written here. So minus 2.7064 is b value, f of a is here, f of b we have calculated from here, which is same value. So we get minus 2.7072. If we calculate f of x, again it is negative. But for correct to 3 decimal places, this is correct, minus 2.707. So therefore the required root is x equal to minus 2.707. Thank you.